Just imagine for a moment, the world you see, the objects you touch, time, memories, pain, love, death. What if none of it is base reality? What if this entire universe is a massive simulation created by an unimaginably advanced civilization? This idea used to belong only to science fiction. Movies like The Matrix made it popular. But today, this question is no longer confined to cinema. Real scientists, philosophers, and technology billionaires are seriously discussing this possibility. For example, Nick Bostrom or Elon Musk. So are we really living in a simulation? Is science actually taking this idea seriously, or is this just a modern myth? Today, we're going to explore this in depth. 1. What is the simulation theory? In its simplest form, the simulation hypothesis says, the universe we live in is not fundamental physical reality. It is a highly advanced computer simulation running in a higher level of reality. The modern version of this idea was proposed in 2003 by Nick Bostrom. Bostrom argues that one of three possibilities must be true. Civilizations go extinct before reaching technological maturity. They reach maturity but choose not to run ancestor simulations. If they do run them, the number of simulated conscious beings vastly exceeds the number of real ones. And if the third possibility is true, then the probability that we are in base reality may be extremely small. 2. Why does Elon Musk say the odds are 1 in a billion? Elon Musk has stated in interviews, the odds that we're in base reality is 1 in billions. What's the reasoning behind that claim? Look at video games. In the 1970s, there was Pong. Today, we have hyper-realistic virtual worlds. Technology advances exponentially. If that trend continues, hundreds of years from now, computers capable of simulating conscious beings might exist. And if a civilization can do this once, they could run millions or billions of simulations. Statistically, wouldn't it be more likely that we are inside one of those simulations? 3. Quantum physics and the coded nature of reality. This is where things get even more interesting. Modern physics shows that at its foundation, reality behaves strangely. A. Quantum uncertainty. Werner Heisenberg introduced the uncertainty principle, which states that a particle's exact position and momentum cannot be known simultaneously. Why? Why is reality fuzzy? Think of a video game. The game only renders in high resolution what you are looking at. Some physicists draw parallels between this and the idea of a rendered universe. Is this proof? No. But is it thought-provoking? Absolutely. B. The double-slit experiment. First conducted by Thomas Young and later refined, the double-slit experiment showed something astonishing. When not observed, particles behave like waves. When observed, they behave like particles. Does reality depend on observation? If so, could this resemble a simulation engine optimizing processing power? Again, this is not definitive proof, but it raises serious philosophical questions. 4. The mathematical nature of the universe. Why is the universe so deeply mathematical? Albert Einstein was amazed that the universe is comprehensible through mathematics. Physical laws operate like code. The speed of light is constant. There is Planck's constant. There are quantum limits. Some theorists propose that the fundamental layer of reality is not matter, but information. Is the universe, at its core, an information system? 5. The Planck scale, the pixel of the universe. Physics has a lower limit. The Planck length. It represents the smallest meaningful unit of measurement in the universe. There is nothing smaller, like a pixel on a screen. If the universe is not continuous but discrete, does that suggest a digital architecture? Some physicists take this idea seriously. Others argue it is simply a mathematical constraint. 6. Can consciousness be simulated? The most critical question in simulation theory is, what is consciousness? If consciousness is merely a complex information processing system, could a sufficiently powerful computer generate it? Alan Turing suggested that machines could think. Today, artificial intelligence can mimic human language, create art, compose music, but could it one day have subjective experience? If yes, could we also be software? 7. How do scientists approach this? Here is the important point. The simulation hypothesis is not currently testable. For something to be scientific, it must be falsifiable. At the moment, we cannot observe outside the simulation. We cannot measure the system's source code. We cannot communicate with the administrator. For this reason, many physicists view it as philosophical speculation. However, some researchers look for computational limits in physical constants. Does the universe have a maximum processing capacity? Is the speed of light a bandwidth limit? There are no definitive answers yet. 8. The Fermi paradox and simulation theory. Enrico Fermi famously asked, if the universe is full of light, where is everybody? Perhaps the simulation is focused only on Earth. Or perhaps it is running a specific scenario. This is speculative, but it is a possibility some philosophers discuss. 9. If we're in a simulation, why don't we notice? A fish does not know it is inside an aquarium because it has no external reference. If we are inside a simulation, testing the system from within may be nearly impossible, like a video game character trying to measure the processor. 10. Is this theory dangerous? Some critics argue simulation simulation theory could encourage nihilism. If nothing is real, nothing matters. But consider the opposite perspective. What if this is a test? Perhaps morality, consciousness, and choice matter precisely because of that. 11. What is the scientific consensus? The realistic answer. Mainstream physics does not accept the simulation hypothesis as proven, but it does not dismiss it as absurd either. Because the mathematical structure of the universe, the strange behavior of quantum mechanics, information-based physics approaches, do not entirely rule it out. At present, this topic sits at the intersection of physics and philosophy. 12. If we are in a simulation, the most striking question is, what is the purpose? A historical experiment, a consciousness study, entertainment, or are we just a byproduct? And more importantly, can the simulation be shut down? 13. Could we ever prove it? Some theorists suggest, if the universe has limited resolution, if physical constants are discrete, if computational boundaries are discovered, that could be a clue, but definitive proof? Probably not, because if the simulation is advanced enough, it could hide its own glitches. 14. Conclusion. Is science taking it seriously? The short answer, yes, but cautiously. This topic is discussed at prestigious universities, examined in philosophical papers, explored by some physicists, but there is no experimental evidence yet, so the scientific community is not divided. Most consider it speculative, but fascinating. Final thoughts. Now I ask you, if tomorrow it were proven that the universe is a simulation, would your life change? Or would nothing change at all? Because pain feels real, love feels real, fear feels real, even if made of code, experience is real. Perhaps the real question is not, are we living in a simulation? Perhaps the real question is, what is reality? And maybe, we were never meant to know.